is faculty in computer science at UIC, and she is going to tell us about how to use crowdsourcing for crowdsourcing data assessments. Is that amazing? Yeah, more or less. Yeah. She'll explain it better than I ever.
Great, fantastic. So hi, thank you very much for coming, and now for something completely different. So, how many elephants are there in the world? How many are poached every year? How far do the whale pods travel? And how many juvenile turtles survive to adulthood? These are questions that are fundamental to any kind of conservation policy or research about wildlife, and yet we do not know the answers. And to be able to answer this, even these fundamental questions of how many animals of a species are there, it's an expensive question. For elephants, a couple of years ago, the first most comprehensive census of the entire species in Africa of savanna elephants was funded at several $1 million, ending up in about $8 million. Took 2 years using airplane and human sampling. This is not scalable. This is not repeatable. And yet, to know how well we're doing in our policies, how well the species are doing, we need to do it repeatedly. We cannot put enough GPS collars or radio collars on all the animals out there, and there are not enough scientists to watch them all the time. Besides, any kind of tags can be actually harmful to the animals themselves. So what do? Our answer to this is to use images. Today, images are the most abundant, readily available source of information about everything from what we eat to animals, wildlife specifically. And these images are coming from scientists, field assistants, camera traps, drones, autonomous vehicles on land, water, and air, as well as tourists going on safaris and whale watching tours and posting their images on social media. So how do we harness that readily available resource to really map the biodiversity of the planet as well as understand it at the local scale? I love the connection to scale, because we can really go from very local to very global, and we need to. It would be great if we could just look at pictures and figure out what's going on and who's there and give it home. And this is just species. We wanted to go beyond species. So can you take all these pictures, these hundreds of thousands, no, in this case, a couple of thousands of pictures, and find all the elephants in them? I gave you a hint there. So we can, with the help of machine learning, artificial intelligence, and computer vision, we can take all these images coming from all these sources and find which ones have animals in them, where the animals are in those pictures, put a bounding box around each one, so including the baby over there. Did you see the baby? Around every marine animal, such as turtles or zebras, when they are occluding each other. And so not only identify their species, which we do, as I said, using machine learning and state-of-the-art machine learning techniques, we can tell you exactly which pixels are zebra pixels versus non-zebra pixels, and all the other species, but we can identify down to individual animal. So given a photograph of a zebra, we can look at a database of all the reference zebras and tell you that this is Zippy the zebra, and Joe the giraffe, and Terry the turtle, and Willie the whale. And we can do it for anything that has unique markings, stripes, spots, wrinkles, notches, as well as the shape of a whale's fluke or the dorsal fin of a dolphin. And so now, with information on when and where the picture was taken, as well as who is in that picture, we really can build the global view of the species as well as a very local one. And this is Wildbook. So the system that does it is a cloud-based system that we call Wildbook. You know, just like another type of book, but for wildlife. Where you do have the pictures, all the pictures of an animal with the information on who it is. And if the animal was seen with others, we can build a social network of that animal. This is a sperm whale, Pinchy. She's a celebrity. She's the most cited sperm whale in our wild book for cetaceans. 5 species of whales. We just added right whales. I'm excited. As well as 2 species of dolphins that we use both the shape of the fluke. So for Pinchy, the shape of the fluke is the unique thing, the feature that we use to identify her. And so for every sighting, we know the when and where, and quite often with whom, as well as other possibly biological samples and information that we can connect from Wildbook to weather and species biodiversity data set, GBIF and so on, and as well, of course, where the sightings occur. So we map this particular one, sperm whale, is very local to Dominica and is part of the Dominica project. And because we could map her, and she is a celebrity, she spurred, during the hurricane season, particularly the one that was very difficult last year for Dominica, and wiped out the entire island, the people started asking questions. How do whales weather hurricanes? What do they do? And local researchers who are, Shane Jarrett, who is in charge of the Dominica Whale Project, started answering questions about, and that's part of the interest in people's interest in whale research and conservation. In general, so we go beyond researchers' photographs. We can actually take pictures, videos from YouTube. We started piloting this project for whale sharks that have unique spots to identify them. And every day we go through YouTube videos of whale sharks. We find all the new ones. From using natural language processing, we find when and where the whale shark was sighted. Find the frames inside the video that have a whale shark in them, all automatically, and identify who that is. And then we post in the comments on the YouTube video, hey, in your video we found this whale shark, unique individual. It's all generated automatically. There is a bot that starts a conversation. This is the individual we found. This is the first sighting of the year. Here's the link, you can learn more about it, and we send them to the page of Wildbook for whale sharks. And people respond, you can't see it, but that particular response says, oh wow, and you're an AI from all of humanity, please don't conquer us. So, I don't know. Okay, let's go back to the show. You have now a quick replay. Remember all of this? Yes. It will be a test. So, and there are a couple of things that are remarkable here. One is, if we don't get the information on when and where the video was taken, we can post in the comments automatically again, hey, where did you see the shark? And in normal human fashion, or when did you see the shark? In this case, because we see it's Crowdsourcing. So it is Philippines. And then we ask, so when did you see the shark? People answer, oh, last year we went on vacation with all my family. And so there's this human bullying response of when and where, but all we need is March 6, 2000. And so we find that and extract it. There are several projects in this case, several researchers and conservation groups that have this shark in their data set, and they're all sort of seen collaborating here. We started Book for Whale Sharks several years ago with a few hundred known individuals. The entire species assessment, the entire species population size was estimated in 2009, was estimated from the using genetic diversity methods from, wait for it, 70 known individuals. That's the population size estimate that was used by International Union of Conservation of Nature, Red List, the one organization that when we say, that determines the conservation status of species. When we say the species are endangered, it's because they determine so. When we say it's on the red list, it's because that's the red list. So today, we have more than 9,000 known individuals cited, actually this is 3 days old, sorry. So we actually got a big influx of data recently, so it's nearly 53,000 sightings. And together contributed by more than 6,000 volunteers. Most of them are people who went on vacation and then uploaded their video to Wildbook. And 174, now almost actually more than 180 research organizations and conservation projects. But the biggest contributor as of a month ago to the data in Wildbook for whale sharks is the AI intelligent agent that scrapes YouTube videos. So as of a month ago, the intelligent agent has contributed more data than all the humans combined. And it's not sightings of the same individual. The AI agent is the number 3 in the third place in the number of unique individuals that it has cited and contributed to Wildbook. It is remarkable data. And so this is the map of the sightings of the whale sharks in the world. We can start asking questions of not only what's the range, how does it change over the years as the oceans warm, right? Because they're tropical species. We can see hotspots. We can find where the seasonality, the migration patterns. And because these are global species, there is not one group, not one research project, not one conservation organization that have the entirety of data in their database, even on one individual. And you can see for every one individual who are the organizations at the bottom who have data about this individual. And in fact, it is our data that now is the authoritative source for UCN Red List on the whale shark population numbers. Oops. Because when I go back, for some reason it decides that, I don't know what it is, that it doesn't work very well with the clicker. But we'll make it work. Again. Fast replay. Right, so, and last December, the most comprehensive study on the biodiversity of the species was published, co-authored by 36 authors. Majority of them met only through the pages of Wildbook. The first deployment of Wildbook was at Lake Wildlife Conservancy, the only UNESCO World Heritage Site in Kenya. And this was for the Greater Zebras. They're the headquarters of the Greater Zebra Conservation Trust. After deploying it, so they've done assessments of zebra population. Greater zebra is an endangered species of zebra. They've done assessments of the greater zebra populations for over many years, sort of monthly patrols. It took a while, so they would take pictures, then bring back, and it took about 20 minutes to recognize individual zebra by carefully clicking. Remember the early GIS? How you had to click on the outline of the region to sort of get the boundary very, very accurately. So that's how the early days of recognizing zebra, you would click on the outline very, very, very carefully and then match the stripes. And so this was really not scalable. But there were clearly trends that they could notice but didn't have enough evidence to support. With the deployment of Wildbook, they were able to get accurate data on the fact that there are not enough juveniles surviving to adulthood. And the main culprits are lions. Right? So baby zebra are snack. A wonderful barcoded snack. So they're doing such such a great job on lion conservation that there are too many lions for the ungulate and equid populations of Lewa. So with the evidence that they had from Wild Book, they were able to convince Kenya Wildlife Service to start a population management program for lions to put the predator and prey in balance again. Okay. And in 2016, Wild Book enabled the first ever full census of an entire species, that endangered gray zebra, from photographs taken by ordinary citizens. 95% of the zebra are in Kenya, about 5% are in Ethiopia. And for 2 days, hundreds of people from school kids and rangers up north and local tribal chiefs to US ambassador to Kenya, Bob Godek, and tourists with telephoto cameras took more than 40,000 images all over the country, and we identified all the zebras in all those pictures and provided the most accurate, to that day, population census, not estimates, census, with the tightest bounds of the gray zebra, that endangered gray zebra. It was so accurate that, again, it finally convinced Kenya Wildlife Service that this is the way to do census, and they asked us to do it again in this past January. This time more than 1,000 people participated. It was a massive event with a tagline. We provided the platform, but really the work was done by Kenyans in Kenya. The tagline of the event was Kenyans powering conservation. Everybody engaged. Our youngest photographer was 3 years old, because all you have to do is take a picture. It democratizes science and conservation. Everybody can participate. And so with the second census, we finally were able to get the most northern parts of Kenya, which we knew were missing populations there. And this is now the official number, again, that the UCN Red List uses, and just for your entertainment. So this time also giraffes were added to the census, because we've convinced Kenya Wildlife Service that this is a good way of doing census. So reticulated giraffe, the first ever estimate was done this past January, and one of my favorite ones that I saw as we were looking for the data, we call it the emoji giraffe. Do you see the heart and the smiley face? How can you see? Right. So but we're asking the question: can you really do the census? Can you really do science and conservation from pictures? Right. First of all, can you do counts from these kinds of events? And the answer is yes, and I'm happy to talk a lot more about it. But we tested for, first of all, the standard macro capture models, the standard ways of doing market capture make a lot of assumptions that this is actually the first time where these assumptions hold. This is the way to do it. The second thing is we tested for all the spatial independence and all the other variables. And then what really finally convinced everybody is this saturation curve of how many new individuals we saw. And by mid-morning of the second day of the event, there were essentially no new individuals seen. And in the following 2 years, only babies, essentially, 99% of the population we now have a baby. Right? There are no new zebras that we can meet. The dating pool is over. So, and it is now the official authoritative number for UCN Red List. And one of my favorite things when we delivered the results this past January, Kenya Wildlife Service Chief Warden said, "This shows the power of citizen science and machine learning for conservation." This is the first time they've accepted results collected by ordinary people, the first time they've accepted results certified by an outside organization, and the first time they've used the word machine learning in a sentence ever. So we're super excited, and now we're looking at, if we're going to use social media photographs and videos, how biased are the resulting estimates of population sizes? So we're looking at Flickr, and I have several master's project and PhD project starting on, because we need a whole new way, a whole new set of models of leveraging, to be able to leverage this data to provide accurate estimates of ranges, population size, and so on, because there are so many biases that are happening in this process. When we have going from true population, being there at the right time, at the right place to actually take a picture, deciding what pictures, who are you going to take a picture of, right? There's some people that only photograph birds, some that are only going for cats, and some take 1,000 pictures of zebras and for the first hour, and then, okay, I've seen all the zebras. And then what are you going to share on social media? How we're collecting data from social media. Each one of those steps has its own bias, and finally which models we're going to use to produce estimates from all of this. But what we care about is how does it all go back to the original population, to the true population. So we're working on all of this. We have now wild books for more than 25 species ranging from whale sharks and whales and dolphins and manta rays and some marine seals in Finland and lynx in Europe and giraffe in Africa, and one of my favorites, Internet of Turtles. The project was WWF International, which is the true IoT. Okay, so it is machine learning and data science that allow us to go from science and from pixels to science, conservation, and public engagement at both super high resolution and large scale, and spanning all these scales to really engage everybody. And this, talking about engaging everybody, there are thousands of volunteers, citizen scientists, engineers, and scientists and conservation groups that have continued to contribute to this project all over the world for all the species, and we're growing. And most recently, we have become their main supporters. We have a nonprofit that was started called WildMe to host WildBook, and WildMe is a featured partner of Microsoft's AI for Earth initiative, the flagship partner that develops the technology for conservation. Thank you.
Thank you. Applications of the use of social media. So we have a few minutes for questions.
Everybody just right? Yes.
Is there concern about risk to the animals?
Absolutely. Thank you for that question. So on the one hand, using photographs is the non-invasive way of collecting data about animals. On the other hand, it's the data that are geotagged images that are golden for science and conservation are also a great source of information for poachers and wildlife criminals. And so we're highly aware of that and started. So WildBook is secure by design. Notice I only showed you very few actual data points from within WildBook. For endangered species, we don't want to open it. So it is secure by design, and we're working with the world's experts in privacy and security to put the proper privacy and security policy for use of geotagged animal images, in particular the derived data, the aggregate models that are coming out of it, and the aggregate data. So the top world's security conference, UCINEX, the keynote this year was by my collaborator that we're collaborating on the project we call Privacy for Tigers, delivering both the need and the very first designs of how we're going to deal with the security policy for this data.
So, how many companies are you working with in Africa? Because I was in Zimbabwe this year and I never heard of WildBook.
So from idea, the very first thought, to what you're seeing right now is less than 4 years. Actually, 3. What you've seen here is mostly 3 years of, from the very first idea, the very first design, to what you're seeing right now. So we're very new We're quickly growing. We're the only ones in this particular space, so using photographs and identifying down to individuals and building actual platform global scale. So we're truly spanning the global scale platform. There are maybe related, there are alliances and coalitions and sort of consortia that are being built now of this rapidly growing space of tech for conservation. The last Tuesday, there was a National Geographic headline article about Wild Book and Wild Me, but also talking about other tech for conservation initiatives from Wild Labs and Wildlife Insights and others.
Yeah.
You decide. Go for it.
Do you see any use for trying to talk to folks with like Facebook and LinkedIn and other places where they're walled garden and somehow find ways to have access to those pictures?
We are.
Yeah.
We are.
Good. And
Talking.
Are you making a lot of progress?
It's a very careful, because there are human privacy issues.
Right.
Yeah, so it's a delicate balance of getting access to data, not exposing that data to poachers, protecting the privacy of humans as well as protecting the privacy of animals. But we're talking.
And also fake data, right?
Then we can actually tell. We're able to tell whether they, because even for whale sharks, there is a Chinese airline that has whale shark as its logo. There are lots of whale shark and zebra images that are they're fake. There are zoo animals, there are aquarium animals. We're able to handle that, particularly because we can actually identify individuals. Yes.
As far as identifying individuals, obviously the markings can vary on one individual from the left-hand side to the right-hand side.
Great question.
So, can you build 3D models of
Yes.
the individuals? And can those models change over time? Because those markings are subject to, you get attacked by a lion, you may lose a chunk of skin, you may not look like the same individual anymore. And so
It's
how do you
a great question. So yes, we can build the 360 wraparound very quickly because, so at the beginning, if you purely have left and right side, then we won't be able to tell that it's the same individual, which is why we build models for animals like zebras, purely from left side and purely from right side. So we're not overestimate the population size, and then sort of keeping but very quickly once you have the left back right, you can build wraparound very quickly, and we connect the images of the same individual pretty quickly. We're working with researchers at Max Planck Institute in Germany to actually build 3D models from these various found images and crowdsourced images. And the reason it is really good is to build because size, particularly if you can do it reasonably accurately, size and shape is a good proxy for health of an animal and the population. So if you can do that, that's great. We started that project as a sort of museum piece for Sudan, because we had all the 3D, the last male northern white rhino who died 2 years ago now, I think, a year and a half ago, in Kenya at the Old Peshte Conservancy. So we had, before he died, we had all the 3D, 360 sort of pictures, and so building the 3D representation of the rhino. But yes, and to answer the second question, in terms of markings, they're actually, one of the uses of technology that we have is to identify when animals have scars, and so we're working on this and figuring out, because there's a lot more information in the markings, for example, for turtles, to allow us to identify that it is the same individual even when they have scars and notches, and they preserve from childhood. For zebras, for example, we can say from childhood to adulthood. We can also tell when a zebra is pregnant. from the photographs because the relative topology of the markings remains, but they're distorted in a specific way. Yeah.
I know that there are 1,000 more questions, but we do have to move on to the next presentation, so thank you, Tanya, very much.